Hello friends, welcome to my channel Clinical Biochemistry by Dr. P.K. Prabhakar. Today I am going to talk about one of the common things which we are using in the in our kitchens, red cabbage or the cabbage. So we will see how this red cabbage can be used as a pH indicator, and this indicator you can make in your home also. So first we will see what we call indicator. What do we mean by indicator? So normally this indicator we are talking, whatever indicator we are talking here is, that is a pH indicator. So this pH indicator is a halochromic chemical compounds which normally we use to detect the acidity or basicity of any solutions in the labs. So by seeing the color changes, we can normally see that it is acidic solution, or it is a basic solution, or it is a neutral solution. So we are just going to visualize the color changes, and on the basis of that one we will define, we are going to say that acidic or basic solution it is. So a pH indicator, that is a chemical indicator, because you know that acidity or basicity of any compound depends on the presence of H plus ion or the absence of H plus ion, or you can call it presence of OH minus ion. So actually these indicators normally detect the presence of H plus ion. So normally this H plus ion present in two forms in our solutions. Either it will be present in the hydronium ion H3O plus, or it will be present in the hydrogen ion, that is proton, that is H plus ion. So normally these indicators causes the color of the solution changes depending on the pH, depending on the H plus presence. So if more H plus will be there, so that will be acidic solutions. If less H plus will be there, that will be or more OH minus will be there, that will be basic solutions. So actually they are going to change the color of the solutions. These indicators can also, every time it is, means all the indicator whatever we are going to use in the solutions in the means labs, they all does not work through the color changes only. There are some indicators which also works through the physical property changes, like some of the olfactory indicators show change in their odor. It's not color changes, their smell will change, how it fumes will come and how it will feel, that odor will change. So every time it is not color changes only, it is their other physical property also going to change during the indication or indicators. The pH value of a neutral solution is 7 at 25 degrees centigrade at normal laboratory conditions. Solution with the pH value below 7 are considered as acidic, and whose pH will be above 7, that will be considered as basic. That is the normal, we are knowing it. So these are the different common indicators which commonly we are using. Like if you see any indicators, like we are going to say first one, thymolphthalin. So that will be at lower acidic pH, it will be color, means a lower pH, it will be colorless, and when it will be going for higher range, it will be blue in the color. And this pH, this indicator you can use between this range. Similarly thymolphthalin we can use in other indicator also, like that it will be lower pH range, it will be red, and higher pH range it will be colorless. So it will be between this range you can use it. Thymol blue you can use in two different kind of ranges you can use it, between 8 to 9.6. so it will be yellow and blue, and 1.2 to 2.8 means both acidic and alkaline range you can use. Phenolphthalein you can use in three different range. So these are the common indicators which we are going to use commonly in our labs. But these things normally we purchase it, we procure it from the suppliers. So what we are going to see, that common kitchen vegetables, yeah, whatever normally we are using in the kitchens. So that is one of the common vegetable is red cabbage. Its a botanical name is Brassica oeleacea. So how this will be used as a indicator, how we can make a indicator from this one. So this is red cabbage. If you see this red cabbage, it contains a specific dye, means because of this specific dye only its color will be red, and that dye is anthocyanin. This anthocyanin is going to be used as a pH indicator, which is going to change their color according to the acidity of the solution or the basicity of the solution. So this, it is a red, pink or magenta in the acid, that is pH below 7, purple in the neutral solutions, that will be at 7 pH, and ranges from blue to green to yellow in alkaline solution. Means same anthocyanin, whatever we are going to get from the red cabbage, will give you ranges from 1 pH, you can measure from 1 pH to the 14 pH, means all the pH ranges you can measure with this one. So that we will see later on how we will prepare and how we can use it. So this anthocyanin is not present only in the red cabbage, it can be present in the different places, other places also. So not only red cabbage you can use it, you can use other components, other vegetables, yeah, other fruits also for this pH indicator preparations. So this anthocyanin, like from the red cabbage, you can use cabbage, or you can use their leaves also. Flowers like geranium, poppy, and rose petals, there you can use it. Berries, that is blueberries, you can use it. Black currant, you can use it. Stem, guava, you can use it. So everywhere it is anthocyanin. That anthocyanin, normally it is a chemical compound, it is a group of compound. So what anthocyanin, why plants contains anthocyanin, and what is the use of this anthocyanin in the plants? So there are few characteristic features this anthocyanin do in the plants. The first, it is going to attract pollinators like bees, then butterflies, then other insects. So it attracts the pollinators and herbivores so that their seeds will be dispersed. Normally dispersal is one of the important characteristic feature in the plants. So for this seed dispersal and the pollinations, they attract. So then it also protects from the cold stresses. It is having antioxidant properties in this anthocyanin is having. So it protects from the cold stress. It deterring herbivores that are attracted to the green color green. And allelopathy, normally its color will be different colors. So normally those plants, those in animals which comes attracted because of the green colors, so that will be detracted. And then it is allelopathy, for example that red anthocyanin in maple leaves stunt the growth of nearby samplings. So these are some of the important properties. One important property which is not mentioned here is their antioxidant properties. So anthocyanins have a very good antioxidant properties, and that is also going to help plants for their protections in different things. Now how we are going to use this anthocyanin or this red cabbage for the production of these indicators. So these are the four important steps we are having. First, whatever components we are going to, if you are going to use this red cabbage or any other fruits or anything, so first make it a small pieces. So roughly chop the cabbages, then you can boil it for few minutes. Either directly you can boil it, or you can chopped cabbage, you can put it in the boiler and you can grind it. So means ultimately it should be in the boiling water. After that you are going to strain and let it cool, and then you can use directly that solution as indicators. So that is these are the steps. Chop the cabbage into small pieces until you have roughly 2 cups of chopped cabbage. Place this cabbage in a large beaker or other glass containers and add boiling water or to cover the cabbage. Allow it for 10 minutes for the color to leach out the cabbage. Either you can use first chop it, put it in beaker and then boil it, or you can place about 2 cups of cabbage in a blender, cover it with the boiling water and then blend it. So both way you can do it. Once you will get it, then you are going to filter out the plant material to obtain a red, purple, bluish color, some substance like this one, and this liquid is at pH 7. The exact color you get, that depends on the pH of the water. Now whenever you are going to use it, this will be your indicator. Whenever you want to use it, roughly use 50 to 100 ml of this red cabbage indicator solutions into 250 ml of beaker, and you can see the color changes. So this is the roughly mechanism. This is a flavin. So at a different pH it is going to show you different kind of colors. So that will be depending on its protonation or proton releasing. Means every time either it is going to get the protons or it is going to release the protons. So because of that behavior only the color is going to change, and later I will show it to you. This is the how this anthocyanin is going to show you the color. So anthocyanin normally changes the color in different pH leaves because of the molecular structure. Actually shifts at the pH of the solution. They are in the change from acidic to the basic, and vice versa you can call it. This makes these anthocyanin pigments unique compared to the other natural colors. Like at a low pH of around 3, means you can call it acidic pH, where solution will be having high amount of protons. So in that case, at acidic pH, this anthocyanin will be highly protonated. So you can see at this place and at this place. So this is a protonated solution. So it will be protonated at these two places. Means it will be in the proton. This means the phenolic OH group, which is shaded in the gray, have high hydrogen. In this environment, the anthocyanin is a positive ion or cations. it absorbs light in the blue-green spectrum around 450 to 560 nanometers and appears ready to the human eye. At the pH of the environment increases, as you are going to increase it, so slowly this will be going to donate their proton or release their proton. So from, like here you can see the differences. So one of the proton had been released from here, and slowly its absorption peak is going to change. So when you are going to put it in the basic ranges, so both the protons has been released from both the places, and so it is called as deprotonated forms, means proton are removed from the phenolic groups, and the light absorption of the molecule shifts, now absorbing light at different range, that is yellow orange spectrum. You can call it 570 to 620 nanometer range. Okay, so this anthocyanin, that is a group of compound. They are natural water soluble pigments which is responsible for the different colors in the plants, as you have seen. We are going to see later on also. So this anthocyanin gives blue color to the different components of the leaves. You have fruits, you have flowers, purple color, pink color, red color, and sometimes fruits also you are going to see the change in the color of fruits, like when it will be unripe fruits, it will be green or it will be white, and once it will be ripened, it will be red. Similarly, leaves also, when leaves will be young, it will be green, and at the age of when it will be going to setting, at the setting time, it will be normally yellow or red, like that one. So these are because of the changes in the different anthocyanins only. So this, why anthocyanin changes color, that is because of the protonation and deprotonations. So you can say, you can start like at 7 pH, you will see this type of anthocyanin solution, which we are going to prepare it. And if you are going to mix in the acidic solutions, it will give you red pigment, or if you go to the basic solution, it will be yellowish type of orange type of things, and that will be because of the protonations. Like here you can see this is the protonated OH in both the cases. So as you are going to increase its charge in pH, normally it will be deprotonated, and ultimately it will be deprotonated. So because of the proton deprotonated and deprotonated forms, it is going to give you different type of compounds, means anthocyanin will be converted into different compounds, different forms, protonated or deprotonated, and that gives you different colors. So if you'll see this anthocyanin, I have told you it is a group of compound which will have different types of color and different specific plants, different flowers will have different colors. That will be because of these different groups of anthocyanins. Like you can see here, this is pelargonidine. If this compound will, this category of anthocyanin will be present in some parts of leaves, their color will be like this one. If petunidine will be present, this will give you this color. If delphinidine will be there, this will give you this type of color. So means this anthocyanin is responsible for the different types of color in the different parts or different flowers or different fruits. So like you can see here, this cyanidine, which is normally present in the grapes, blackberry, blueberry, canberry, raspberry, apples, and cabbage, and they will be also going to be used as an indicator. If pH will be more than 11, it will be blue color. If pH ranges will be 3 to 11, it will be purple. If pH range will be less than 3, it will be red. So you can identify in which range it is. Similarly, you can use all other anthocyanins like delphidine. They also have these colors. Malvidine, they also gives you this color. Pelargonidine, they have only one color at all the pH. Peonidine, they will have 4 different colors. So these are on the basis of these things, you can use different anthocyanins for different pH indicator for different ranges. So this is all about how you can create a homemade indicators for different pH ranges in your home from your normal vegetables only. Not only this one, if you have rose petals also, you can, from the rose petal also, you can go for same process and you can get you can make the indicators. So this is all about how you can make a pH indicators from your kitchen or from your vegetables. If you like the video, press the like button. If you are not subscribed my channel, please subscribe it. If you have any questions, anything related to this video or anything else in the biochemistry, molecular biology, microbiology, you can write in the comment box. You can message me on any of the social networking sites. I will be happy to give your answers. So thank you very much. Normally you are coming and watching video but not subscribing. Please subscribe my channel also and support us. Thank you very much. Have a nice day.